If you're like me, then there's a good chance you've been affected by the microchip shortage. Maybe you were planning to upgrade your PC, only to find out that all the new graphics cards cost more than a used car, or maybe you were hoping to get your hands on the latest phone, only to discover it was delayed for months. The fact is, we're reliving in extraordinary times where it seems like everything is harder to buy and no one seems to know when things will go back to normal. And believe it or not, the root cause of these shortages can actually be traced back to the same thing: microchips. These little pieces of silicon are everywhere these days. They're in our phones and computers, televisions and thermostats, cars and coffee makers. In other words, if it has a processor, then it needs a microchip. But there's a lot more to these chips than meets the eye. And the reality is, we're facing a global shortage that will likely last longer than you think. So here's why the world's microchip crisis will last longer than you think. Take a second and look at the device you're watching this on. It could be a phone, a computer, a tablet, or even a smart television. No matter what it is, chances are it contains a microchip. This is basically a small piece of semiconductor material, most commonly silicon, that has been designed and manufactured to perform a very specific task. In essence, they're like miniaturized brains that process and store information in binary code. In other words, ones and zeros. Every microchip is made up of billions of tiny switches called transistors. And the smaller the transistor, the faster and more efficient the chip. For example, the latest A15 Bionic chip in Apple's newest iPhone contains roughly 15 billion transistors that are only 5 nanometers in size. That's about 30% smaller than the last model. And to put that in perspective, each transistor is about 20,000 times thinner than a strand of human hair. It's hard to overstate just how far chip technology has come over the years. In fact, according to Moore's law, the number of transistors that can be placed on a microchip doubles about every 2 years. This means that each generation of processor gets twice as fast while taking up half the space, which is why today's smartphones are so powerful, but also so tiny. Of course, this isn't just limited to smartphones either. Almost any electronic device that you can think of has a microchip inside of it. For example, a typical vehicle now contains around 3,000 microchips that control everything from the infotainment system to the anti-lock brakes. In fact, there are so many microchips in modern cars that some manufacturers are having trouble finding enough to meet demand. This is why there have been so many headlines about microchip shortages and delivery delays. But believe it or not, the price of these chips has also gone up drastically. Back in 2020, an advanced microchip used in high-performance PCs would set you back about $1. Today, that same chip is going for $150. And if you're skeptical and wondering how much of a price increase that really is, let me put it in perspective. If you were to buy $100 worth of microchips in 2020, you would get $100 worth of microchips. Today, however, you'd only get 67 cents worth of microchips because they've gotten so expensive. But before we get into why that is, I want to take a moment to explain how these chips are made, because it turns out that manufacturing microchips is one of the most difficult processes in the world. It's kind of like baking a cake, except instead of flour and sugar, you're working with pure silicon and chemicals. The first step is to grow an extremely thin slice of silicon crystal. This is typically done by melting down pure silicon and then slowly cooling it down. Once the crystal is grown, it's sliced up into thin wafers that will eventually become individual chips. At this point, the wafers are still basically just blank slates. So the next step is to add layers of conductive materials such as copper and aluminum. These layers act as pathways for electrical signals to travel throughout the chip. But as you might imagine, placing them with pinpoint accuracy down to the nanometer scale is incredibly complicated. To do this, the wafer is coated with a light-sensitive chemical that acts as a mask. Then a series of lasers etch away all the areas that aren't supposed to have copper. After the laser passes, another chemical is applied to fill in the empty spaces. Once it's dry, the wafer is then coated with yet another layer of light-sensitive chemical, along with a layer of aluminum. The whole thing is then exposed to UV light, which etches away the areas that aren't supposed to have aluminum. After the aluminum is applied, the wafer goes through several more rounds of masking, etching, and layering until the desired design is complete. At this point, the individual chips are cut out of the wafer and then mounted on the packages. These are basically little circuit boards that provide power and connections to the outside world. From there, the chips go through rigorous testing to ensure that they meet specifications, and those that don't get weeded out. After that, they're ready to be shipped off to companies who incorporate them into their products. But as you might imagine, manufacturing microchips is extremely difficult and prone to errors. Even the smallest mistake during the fabrication process can render an entire batch of chips useless. On top of that, you need specialized equipment that costs millions of dollars and facilities that are kept at a constant temperature with minimal vibrations. These fabs, as they're known, have to be built inside large warehouses where they take up as much space as several American football fields and employ hundreds of people. So given all this, it's clear that microchips aren't exactly easy to make, and scaling up production isn't as simple as just throwing more money at it. But that is not to say that it hasn't been tried, because since the onset of the pandemic, basically every major chip manufacturer has announced plans to invest billions of dollars into new facilities and expand their capacity. But as we all know, building factories doesn't happen overnight. In fact, even after breaking ground, it can take a year or longer before a fab is fully operational. On top of that, there are only a handful of companies in the world that manufacture chips at the leading edge. For example, Taiwan Semiconductor Manufacturing Company, better known as TSMC, is currently the largest contract manufacturer of microchips in the world. They produce roughly 92% of the world's leading-edge chips. Other notable manufacturers include Samsung and GlobalFoundries. But even with all these companies expanding their operations, it's unlikely that supply will catch up with demand anytime soon. And that's largely because demand for microchips keeps increasing. As consumers get more and more used to having powerful devices with sophisticated processors, they expect the same level of performance from everything they buy. For example, remember when the PlayStation 5 came out? Well, it quickly sold out because it could render games at 4K resolution, a big improvement over the previous model. But had you bought the PS5 back in 2020, you probably noticed that it didn't come with a disk drive. That was because Sony went all in on digital downloads, which allowed them to save on manufacturing costs. But the problem is that most of their customers weren't on board. 85% of gamers preferred physical media, which meant that Sony ended up with a ton of unsold PS5 South, and that's just one example of how supply chain issues can arise when trying to predict consumer demand. The reality is no one knows exactly what's going to sell and when, which makes it nearly impossible to forecast demand accurately. But even if they did, microchips are such a critical component that companies hate to be caught holding too much inventory. That's why most of them prefer to keep just a few weeks' worth of stock on hand. So if demand unexpectedly surges, then they end up scrambling to place new orders, which puts more pressure on the supply chain. And with lead times stretching out to 2 years, companies are forced to make tough decisions. For example, should they hold off on launching their new product until they can secure enough chips, or should they risk it and see how many they can get? Either way, the consequences are dire. If they don't get enough, they'll lose out on sales. But if they order too many, then they could end up with excess inventory and wasted resources. And let's not forget that the pandemic is still going on. Factory shutdowns, labor shortages, and transportation issues are still causing disruptions that are felt across industries. But it's not all bad news. While it's true that the microchip shortage will likely last longer than you think, it has forced companies to get creative. For example, some automakers have started buying chips directly from chip manufacturers instead of going through distributors. Others have begun pooling their resources and sharing inventory. Ultimately, the microchip shortage is a wake-up call that we shouldn't rely on just a few companies to supply us with these critical components. We need to diversify our supply chains and invest in new technologies. Otherwise, the next time something goes wrong, we could be in real trouble. Do you think the microchip shortage will ever end? Comment below. Also be sure to subscribe for more.